Continuous loads, as defined by the National Electrical Code, require specific considerations when calculating electrical loads. The fundamental principle is that continuous loads, which are loads expected to operate for 3 hours or more, must be accounted for at 125% of their rating. This ensures that the electrical system is capable of handling the sustained demand without overheating or experiencing voltage drops that could damage equipment or create hazardous conditions. The question of whether continuous loads can be derated according to tables 220.11, 220.13, 220.18, 220.19, 220.20, and 220.32 of the National Electrical Code is addressed directly by the code. Specifically, Article 220.11 Code provides a clear and definitive answer. This article states that continuous loads in lighting and appliance branch circuit shall not be derated. This means that the standard practice of applying a demand factor or derating factor to reduce the calculated load does not apply to continuous loads in these specific types of circuits. The implication of this rule is significant for electrical design and installation. Firstly, it reinforces the importance of accurately identifying continuous loads within a system. This requires a thorough understanding of the operational characteristics of the equipment being installed and the expected duration of its use. Secondly, it highlights the need to calculate the branch circuit and feeder sizes based on the full continuous load, plus any non-continuous loads. This calculation directly impacts the selection of conductors, overcurrent protection devices, and other components of the electrical system. Thirdly, the prohibition of derating ensures that the electrical system has sufficient capacity to handle the sustained load. This reduces the risk of overheating, insulation breakdown, and other potential hazards associated with overloaded circuits. The specific reference to lighting and appliance branch circuits in Article 220.11 Code is also noteworthy. Branch circuits are the final circuits in the electrical system that supply power to outlets, lighting fixtures, and appliances. Because these circuits directly serve the end-use equipment, the loads they carry are particularly important to consider. The National Electrical Code provides various tables and articles to guide the calculation of electrical loads. Table 220.11 provides general lighting loads by occupancy, and these loads must be calculated based on the volt-ampere per square foot requirement specified in the table. The calculation of the general lighting load is a crucial step in determining the overall electrical demand of a building. It ensures that the electrical system can adequately support the lighting needs of the space, contributing to both functionality and safety. The process involves multiplying the floor area of the building by the volt-ampere per square foot value corresponding to the occupancy type. The resulting figure represents the total volt-ampere load for general lighting, which is then used in subsequent load calculations to determine the appropriate size of service equipment and feeders. Table 220.13 addresses receptacle loads in dwelling units. It allows for the application of demand factors to general use receptacles, which can reduce the calculated load. However, it's important to note that specific receptacle loads, such as those serving dedicated appliances, may not be subject to these demand factors. The use of demand factors for receptacle loads can help to avoid oversizing the electrical system while still ensuring that it can meet the actual demand of the dwelling unit. Table 220.18 covers the calculation of motor loads. Motor loads are treated differently due to their unique characteristics, such as high inrush currents during startup. The code specifies that the largest motor load must be calculated at 125% of its full load current, with the remaining motor loads calculated at 100%. This approach accounts for the potential for multiple motors to start simultaneously, which can place a significant strain on the electrical system. It also ensures that the conductors and overcurrent protection devices are adequately sized to handle the motor loads without causing nuisance tripping or overheating. Table 220.19 provides guidance on the calculation of range loads. Range loads are also subject to specific rules due to their high power consumption and intermittent operation. The table allows for the use of demand factors based on the number of ranges installed. These demand factors recognize that not all ranges will be operating at full capacity simultaneously, which can reduce the overall load on the electrical system. However, it's important to carefully consider the specific characteristics of the ranges being installed and the potential for simultaneous use when applying these demand factors. Table 220.20 addresses non-coincidental loads. Non-coincidental loads are loads that are unlikely to operate simultaneously. The code allows for the exclusion of the smaller of two non-coincidental loads from the total load calculation. This can help to avoid oversizing the electrical system when two loads are not expected to be in operation at the same time. Examples of non-coincidental loads include heating and cooling equipment or electric vehicle chargers and other high-demand appliances. Table 220.32 pertains to optional calculation for additional loads in existing dwelling units. This allows for a more streamlined approach to calculating the load of new appliances, with a focus on energy efficiency and modern appliances. When applying this calculation, factors such as the efficiency of heating and cooling systems, the presence of energy-efficient appliances, and the overall energy consumption of the dwelling unit are taken into account. This approach can result in a more accurate assessment of the actual load on the electrical system, which can help to avoid unnecessary upgrades and costs. While these tables provide guidance on calculating various types of loads, Article 220.11 Code specifically prohibits derating continuous loads in lighting and appliance branch circuits. This means that even if a particular table allows for demand factors or other reductions in load calculation, these reductions cannot be applied to continuous loads in these specific circuits. The reason for this prohibition is to ensure that the electrical system is adequately sized to handle the sustained demand of continuous loads. Derating continuous loads could lead to undersized conductors, overloaded circuits, and potential hazards. Therefore, it is essential to adhere to the rule in Article 220.11 Code and calculate continuous loads at 125% of their rating without applying any derating factors. In practical terms, this means that when designing or installing lighting and appliance branch circuits, any continuous loads must be identified and calculated accordingly. For example, if a lighting fixture is expected to operate for 3 hours or more continuously, its load must be calculated at 125% of its rated wattage. Similarly, if an appliance is designed for continuous use, its load must also be calculated at 125% of its rating. The resulting value is then used to determine the appropriate size of the conductors and overcurrent protection devices for the branch circuit. It's important to note that the prohibition of derating continuous loads applies specifically to lighting and appliance branch circuits. Other types of circuits, such as feeder circuits or service entrance conductors, may be subject to different rules and may allow for the application of demand factors or other reductions in load calculation. However, even in these cases, it's crucial to carefully consider the specific requirements of the National Electrical Code and to ensure that the electrical system is adequately sized to handle all expected loads. In summary, Article 220.11 Code of the National Electrical Code prohibits derating continuous loads in lighting and appliance branch circuits. This rule is essential for ensuring the safety and reliability of electrical systems. By adhering to this requirement, electrical designers and installers can minimize the risk of overloading circuits, overheating conductors, and creating potential hazards. The National Electrical Code outlines the specific requirements for calculating electrical loads, and the prohibition of derating continuous loads is a critical aspect of these requirements. When determining branch circuit and feeder sizes, it is crucial to account for the continuous nature of certain loads and apply the appropriate factors to ensure the electrical system's capacity meets the demand. Continuous loads are defined as loads that operate for 3 hours or more. Article 220.11 Code emphasizes that these loads in lighting and appliance branch circuits must not be derated, meaning they must be calculated at 125% of their rating. This provision ensures that electrical systems can handle sustained demands without overheating or experiencing voltage drops. The implications of this rule are significant for electrical design and installation. It underscores the importance of accurately identifying continuous loads and calculating branch circuit and feeder sizes accordingly. The selection of conductors, overcurrent protection devices, and other components must be based on the full continuous load, in addition to any non-continuous loads. By preventing derating, the code helps minimize the risk of overheating, insulation breakdown, and other hazards associated with overloaded circuits. The National Electrical Code offers guidance through various tables and articles to calculate electrical loads accurately. Table 220.11 provides general lighting loads by occupancy, requiring calculations based on volt-ampere per square foot values specified for different occupancy types. The calculation of general lighting loads is a fundamental step in assessing the overall electrical demand of a building, ensuring the electrical system can adequately support lighting needs. Table 220.13 addresses receptacle loads in dwelling units, allowing for demand factors to be applied to general use receptacles, which can reduce the calculated load. However, specific receptacle loads, such as those serving dedicated appliances, may not be subject to these demand factors. Table 220.18 covers motor loads, accounting for their unique characteristics like high inrush currents during startup. The largest motor load must be calculated at 125% of its full load current, while the remaining motor loads are calculated at 100%. This approach accommodates the potential for simultaneous motor starts, ensuring conductors and overcurrent protection devices are adequately sized. Table 220.19 offers guidance on range loads, allowing for demand factors based on the number of ranges installed. These demand factors recognize that not all ranges will operate at full capacity simultaneously, potentially reducing the overall load on the electrical system. Table 220.20 addresses non-coincidental loads, which are loads unlikely to operate simultaneously. The code allows for the exclusion of the smaller of two non-coincidental loads from the total load calculation, avoiding oversizing the electrical system when two loads are not expected to be in operation at the same time. Table 220.32 pertains to optional calculation for additional loads in existing dwelling units. This provides a more streamlined approach to calculating the load of new appliances, considering factors such as energy efficiency and modern appliance design. In practical applications, adherence to Article 220.11 code means that when designing or installing lighting and appliance branch circuits, any continuous loads must be identified and calculated at 125% of the rated wattage. For instance, if a lighting fixture is expected to operate continuously for 3 hours or more, its load must be calculated at 125%. Similarly, appliances designed for continuous use must also be calculated at 125% of their rating. The resulting value is then used to determine the appropriate size of conductors and overcurrent protection devices for the branch circuit. The prohibition of derating continuous loads specifically applies to lighting and appliance branch circuits. Other circuit types, like feeder circuits or service entrance conductors, may be subject to different rules and may allow for demand factors or reductions in load calculation. Even in these cases, careful consideration of the National Electrical Code's requirements is crucial to ensure the electrical system is adequately sized for all expected loads. In summary, Article 220.11 Current of the National Electrical Code prevents the derating of continuous loads in lighting and appliance branch circuits. This rule is essential for maintaining the safety and reliability of electrical systems. By following this requirement, electrical designers and installers can mitigate the risk of overloading circuits, overheating conductors, and creating potential hazards.